Okay, in section 3.4, we're going to solve equations with variables on both sides. Okay, some key terms for this section is identity. Okay, identity would be something that is itself. Okay, so the identity property for addition is when we add 0 to something and we get that thing, whatever it is. So 8 plus 0 is 8. Okay, the identity for multiplication is 4 times 1, anything times 1 is itself. Alright, variable term. A variable term is a term that has a variable in it. So a variable term is something like 2x or negative 3y. Alright, in this unit we're going to be eliminating variable terms from one side of the equation in order to solve for that variable. Okay, coefficient is the number in front of the variable. So like 4x, the coefficient is 4. That's coefficient. Alright, and if you look back to variable terms, 2 is the coefficient for that variable term, and negative 3 is the coefficient for negative 3y. Alright, so let's look at some multi-step equations. Alright, with multi-step equations, we have to follow the acronym DLEAM. Okay, this will help us solve multi-step equations by solving for the variable. Okay, the first step is, alright, do we have to distribute? Do you see any signs of distribution? Are we going to distribute any numbers throughout? And in this case, no, there's no distribution. Okay, the second step is like terms. Can we combine like terms on either side of the equation? Okay, so I'm going to look at, and don't write this, I'm just going to isolate this. Are there like terms on this side of the equation? Are there like terms on this side of the equation? So you look on the left side of the equation, are there like terms? No. You look on the right side of the equation, are there like terms? No. Alright, we have negative 3x on the right side and negative 4, they're not alike. 5x and 12 are not alike. Okay, so in this situation there is no like terms. Okay, the next step is to do the inverse. Oops, let's go back to red. Inverse. Okay, in this case, we're going to move the terms. Alright, we're going to use the inverse for terms. Okay, so we want to get all the x's on one side of the equation and all the numbers on the other side. Okay, so what I'm going to do is I want an equation, I want just x's on one side. So what I'm going to do is I'm going to get rid of this 3x. Okay, this whole variable term from the right side of the equation. Okay, that will cancel it out over here because negative 3x plus 3x is 0x. Alright, and what we learned in the previous section is that whatever you do to one side, you have to do to the other side of the equation. Now I'm going to write plus 3x over here because it's a like term with 5x and I'm going to end up combining them. Alright, so whatever I do to one side I have to do the other, and this will get only x's on one side of the equation. So 5x plus 3x is 8x, and I'm going to bring everything else down in my equation. Alright, don't forget this negative sign. It's a common mistake that people would just bring down to 4. Alright, the next step, and we did this before, is can I add or subtract? Alright, are there any numbers that I can add or subtract in my equation? Yes, I have my variable on this right here, so I want to subtract 12 to get rid of it away from my variable. Alright, whatever I do to one side, you have to do the other. Bring down to 8x. Negative 4 minus 12 on the right side is negative 16. Remember, same sign, combine the numbers, and then take the sign. So you get negative 16. Now we're going to multiply or divide. Alright. So we have 8 times x equals negative 16. Since it's multiplication, I'm going to use subtraction to get rid of it, and I get x equals negative 16 divided by 8 is negative 2. Alright, now if I want to check this to make sure I did it right, I'm going to plug in the value of negative 2 into my equation. So 5x plus 12 equals negative 3x minus 4. I'm going to sub in the value for x and see if it works. And you get 2 equals 2, so it worked out. Alright, let's look at some more examples. Okay, remember our order for solving. Okay, distribute. Can I distribute here in my first example? No. Are there like terms on either side? I look on the left side. Are there like terms? No. Are there like terms over here? No. Okay, inverses. Okay, I want to move my terms, my variable terms over. Okay, so I'm going to get rid of this 2x by subtracting it from the right side. Okay, you could get rid of the 4x if you want. I always like to try to get my variables on one side of the equation if it allows me to, if it's quicker that way. Alright, so that cancels out. Whatever I do to one side, I have to do to the other. Alright, combine like terms. 4x minus 2x is 2x. Bring everything else down. Don't forget the equal sign. Alright, now I'm on to the distributive, like terms, inverse terms, and then I'm going to add or subtract. Okay, I have this negative 3, alright, next to my variable, so I'm going to add 3 to get rid of it. These cancel. I have 2x equals 10 left over. Okay, and then I'm going to multiply or divide to get x by itself. Divide by 2, and we get x equals 5. Okay, and we're not going to check that one just for time. Alright, the next example, if you notice, this side there's no distribution. This side there is no distribution. There's no like terms over here. There's no like terms over here. Okay, so we're going to do inverse with the variables. If you notice on this side of the equation right here, there's only an m value. Alright, and what our goal is to get our variables on one side. Well, if all that's over here is variables, let's get all the variables over here. So I'm going to add 3m, which is kind of opposite. I was doing the opposite on the right side in previous examples. This is fine here because what's going to happen is my m's are going to cancel from this side, and I have just m's on the right hand side. Next step is to add or subtract. Now there's no add or subtraction here. We just go straight on to multiplication or division, and we're going to divide 5 on both sides to get m by itself. Alright, and you get m equals 2. Okay. Here's an example, or two examples, where we will combine like terms first. Let me rewrite that. That's messy. Okay, so I'm going to look on the left side of the equation, and I have x's here. I have 4x and 3x. Okay, so 4 plus 3. 4 plus 3, x minus 10 equals 8x plus 7. So 7x minus 10, I just brought down this 10, equals 8x plus 7. Alright, so there was no distributive property. We did like terms. Now we're going to move the x values. Alright, I'm going to get rid of 8x over here. These cancel out. 7 minus 8, different signs, find the difference. Take the sign of the bigger number. So we get negative 1x, bring everything else down. Okay, now we're going to move on to addition or subtraction. We're adding 10 to both sides. Negative 1x equals 17. Alright, and then we're going to move on to multiplication or division. Divide by negative 1 to get rid of the negative sign, and we get x equals negative 17. Okay, combine like terms first, because in this example there's no distributive property. We'll move on to like terms. We have negative 3x and negative 2x. Same sign, combine the numbers, and take the sign. So we're going to get negative 5x, bring down everything else. We have a positive 6, an equal sign, and 11. Okay. We did like terms. Now we're on the inverse x values. We don't have an x value on this side of the equation, so we could skip that. Add or subtract. I'm going to subtract this 6 to both sides. 5 equals negative 5x, and then I'm going to multiply or divide to get x by itself. X equals negative 1. Okay, in this last section, we're going to go over one solution, no solution, or identity, as well as using the distributive property in the meantime. Okay, so what does this mean? Well, one solution is when we get just one solution like our previous problems. Okay, x equals negative 17, x equals negative 1. No solution is, I'll show you in a minute what that's going to look like, and then identity is many solutions. Pretty much when x equals anything, or whatever variable you have. Alright, so let's do this quickly. Probably not going to get onto the too many of these. Alright, so we're going to distribute first. 3x minus 6 equals 2x plus 4. Bring everything else down. Are there like terms on either side? No. Inverse x's. So I'm going to get rid of this x. Alright, 3x minus 2x is x, or just 1x. Minus 6 equals 4. Add 6 to both sides, and we're going to get x equals 10. Okay, this is the one solution example. Alright, the next one, distribute first. Okay, can't distribute on the right side. We get 4x plus 16. 4 times x, 4 times 4. And we have 4x plus 16 on the other side. Now, if you notice, they look the same on both sides. Alright, and if we go to try to solve minus 4x to get rid of it, and this actually cancels out itself. We're left with 16 equals 16. When this happens, when you have a number equal itself, this is identity. Alright, and you're going to get many solutions, which means you could put in any number for x and it will be correct. The last one, distribute. 5 times x, 5 times 1. Like terms, no like terms. Inverse x's. Alright, so I'm going to subtract 5x here, subtract 5x here. These cancel out, and you're left with 5 equals negative 3. This is no solution, because our x gets canceled out. Alright, go on to the practice problems and ask me questions if you have any.